So here what we're interested in, we're stepping up our game a little bit. We're checking for continuity. So I've given you a function. It's a piecewise function. That's what we're studying, right? So we want to know if this function is continuous or discontinuous at x equals 2. And notice x equals 2 is the boundary between our two pieces, right? So remember, the question we would be trying to answer here based on our definition of continuity is this a function we can draw without picking up our pencil? And to answer that question, we have to think a little bit about what the graph looks like, right? So my top piece, my left-hand piece, is a parabola, and I know that because of the x squared. And it opens down, and I know that because of the -2, right? You guys know that. My bottom piece, I'll switch colors for my bottom piece. My bottom piece is obviously a linear function, and it's a downward sloping, negative slope linear function, so it's a line, okay? So what I'm trying to figure out, I'm going to draw two possibilities here. What I'm trying to figure out is whether these two pieces meet up or not, whether they connect. So we have a downward opening parabola, right? And then we have, what's happening with our line? Our line is also negative slope, so straight line, and they meet up. This point is obviously x equals 2. So this is our first possibility. And then our second possibility is that they actually don't meet up. So we have some kind of discontinuity where my line is still downward sloping but does not meet the bottom of my parabola. So we have like open circle, closed circle here, right? So this is possibility number 2. And the question is, without graphing these, how do we determine which of these is the case, right? Well, it has to do with this point. So we're talking about x equals 2 in both graphs here. Notice, you guys may already see where I'm going with this. Notice we have in possibility number 1, and this by the way is our continuous possibility, we have a specific y value. I don't know what it is, but we have a specific y value that satisfies both of these functions, right? So the y value is the same on my parabola as on my line. Whereas in possibility number 2, and this possibility are discontinuous. Really struggle to spell for some reason. Discontinuous. I think that's has two different y's, so we don't know what they are. But if the graphs do not meet up, the y's are going to be different. Okay? So what we're going to do is we're going to check to see if these y's are the same. And if they are, then the function is continuous at this point. And if they are not, they're not. Okay? So we are going to check x equals 2. And we are going to check in our parabola. So 9 minus 2 times 2 squared. And then that gives us, we have 2 squared is 4 times negative 2 is negative 8. So it gives us 9 minus 8, which gives us 1. And then we also have 3 minus 2. We get 1. So my answer here would be something like this would be good. You'd say yes, f is continuous at x equals 2. Remember, that's the point we were talking about, because the y values are equal for each piece. Okay. Now, obviously, if we had gotten 2 up here and 0 down the bottom, or 2 different y values, we'd say no, because they're not equal. I believe Delta Math just asks you yes or no, but you're going to want to do the work and not just guess and check. I want to show you just a couple more cases here. So the first is this case. What I want you to pay attention to in this case, so notice it looks a lot like our last one, right? We have a line and a parabola, and we're looking at x equals 2. But what I want you to notice is the boundaries look different, right? So we have strictly greater than, strictly less than, whereas before we had an or equals 2. Okay? So what that means, think back to the last lesson, is we have a parabola and then a line, and even if they meet up, what I have now is an open circle, right? So that would be that point, x equals 2. And I have that open circle because neither of these rules include 2, right? So this would be, so f is undefined here. So this would be a big old no, right? F is undefined. There's what we call a removable discontinuity. So that's a special case you can run into where the function is not continuous if those bounds don't meet up at all. And then the last example, this again at first glance looks very similar, but this one's actually kind of silly. So we're looking at x equals 2 as our point, but these functions actually meet up at negative 2, right? So in other words, these are not the same. So what that means is, let's look at this a little bit. X equals 2 is just strictly in this piece, right? So x equals 2, 2 is bigger than negative 2. So that piece of the graph, well, that's just a straight line. And then maybe we have x equals 2 here, right? So the answer here is yes, the graph is continuous at x equals 2, the function is continuous. And that's because any linear function is continuous. So if we're not talking about one of the ends, it doesn't really matter what the point we pick is, because we know that linear functions are continuous and parabolas are always continuous, right? There's no holes in any of those. So we will say yes here every time when we're looking at pieces that are not on these boundaries.